Before we do surface area in 3 dimensions and they're in n dimensions, let's do surface area in 2 dimensions. I'm in R2, I have 2 vectors, and the angle between them. And I make a parallelogram. That angle can always be acute without loss of generality, replacing u by minus u if necessary. Replace sine theta in terms of cosine theta. Because cosine I can rewrite in terms of dot products. And now I grind through the algebra. Thinking now u and v as tangent vectors, or columns of a transformation from R2 to R2, it's the absolute value of the Jacobian, just like before. Moving on to R3, which will generalize to Rn, a point and 2 vectors, define a plane. Looking at that plane only, we just do a repeat of the calculation we just did. The difference in this case is that u and v have 3 components. Otherwise, it's the same calculation. Collecting the terms together, just as before, we now have 3 terms. Now, if we think of this as a transformation from R2 to R3, point and 2 vectors, going to a point and 2 vectors through some transformation. Call the output point P. Then dt at P is the vector transformation, where our u and v vectors are tangent vectors. So our surface area becomes the sum of the squares of the 2 by 2 Jacobians. But for R3, that was exactly the length of the normal vector. This is the part that doesn't translate for Rn, because your tangent space is two-dimensional, your normal space is n-2 dimensional. Instead, you look at objects that are n-1 dimensional, so they have codimension 1. Then your normal has n components. Each component is a n-1 dimensional Jacobian. The transition to surface integrals is now easy. Given a 2-parameter object in 3 space, an n-1 parameter object in n space, d sigma is a chunk of the surface. We pull back into the parameter space. And turn our surface integral into an area integral. dA is dt1, dt2, or dt2, dt1, right? Whichever iteration you're doing. For an n-1 dimensional object in n space, the only difference is the normal is replaced by n components. Each component is that n-1 dimensional Jacobian. So the first component is missing the first variable, etc.